Hey, good afternoon, ladies and gentlemen. It is the afternoon, and you know what time it is? Oh yeah, it's homework time. Let's get to work. So today was all about inequalities, wasn't it? Things are bigger, things are smaller. Sometimes they can be equal, sometimes they can't. So we should probably review very quickly what all those pieces mean. When you see them, I want you to be able to associate them quickly. So if you see a symbol like this on the number line, so a dot, either pointing left or pointing right, that is what we call the inclusive symbol. Inclusive. Meaning that it includes everything, so that means it'll either be less than or equal, or greater than or equal. Okay? The other side of things, the snobby one, if you will, the open circle is the exclusive. It's like an exclusive party, an exclusive club. The exclusive is going to exclude things. So this circle is either strictly greater than or strictly less than. In other words, you cannot use a value it's sitting on. This one you can use a value it's sitting on. So right away I'm looking at this guy right here, and this tells me that at 4.5 I cannot include it. It's the open symbol, the exclusive symbol, meaning that right away, before I even start, I know I cannot use number 1, number 4, or number 5. Okay. I have to use something with an open circle, and I definitely see an open circle on these three. Now the second part is I have to read this sign. Now I know this seems silly, but this is the way I always remembered it, so I'm going to tell you the way I remember it. I always remembered it because I think of this thing as like a hungry little beast that wants to eat something, and it'll always eat the bigger of the two numbers. I know that's crazy, but you know what? You're going to remember it. This opens towards the bigger of the two numbers. This is the smaller of the two numbers. So the way to read this correctly is that x is smaller than negative 4.5. So I want x values that will never get any bigger than 4.5, excluding 4.5. So look at this over here. So I want numbers that are less than 4.5. Well, look at this guy. Is that bigger than 4.5? Is it better to have $0 or $4.50? Is it better to be negative 4.5 degrees or 0 degrees? Clearly, this is not the one we're looking for because I want numbers that are less than 4.5. Well, look at this guy. It's open circle. I'm looking at numbers that are smaller than 4.5. This is the winner. Winner, winner, chicken dinner. This is the answer. So I want x. Now this is. I'm going to skip this one. I'm going to go to this one last. Let's do this guy. So x is this symbol, negative 4.5. Well, first of all, check this out. It's the or equal to sign, so I know I'm looking for a closed circle right away. Now, to read this, I want x's that are bigger than or equal to negative 4.5. So I only have 3 candidates. This one doesn't have any shading. Forget about that guy. This x, look at this. I want x's that are bigger than 4.5. So let's go to a test number. Is negative 10 bigger than negative 4.5? Which is better for your bank account, negative $10 or negative $4.5? Nah, not negative 10. Not this one. I'm looking at the others. Let's check out this guy. I'm looking for x's that are bigger than or equal to negative 4.5. Look at this guy. Is that bigger than 4.5? Is that bigger than 4.5? Is that bigger? They're all bigger. So this is a winner for this guy. Bam. Choice 1. I'm going to skip this one as well. Okay, so checking this out. I have x's less than or equal to negative 4.5. That means I'm looking for a closed symbol, definitely closed symbol, and I'm looking for x's that are smaller than the 4.5, which is sitting on. So closed symbol, check out this point, is negative 8 less than or equal to negative 4.5? Yes, it is. So that is going to be my answer. 4. Cross out. Okay, x's bigger than 4.5. Strictly bigger, open circle only. I know this is my only last one, but let's play the game right. Pick a test number, like 3. Is 3 bigger than 4.5? It sure is. Bam, that's why it's number 2. Now let's go back to these weird ones. X is the same as 4.5. Now think about what that says. X is the same as negative 4.5. It doesn't say X can sometimes be bigger than negative 4.5. It doesn't say X can be this and other things. It says x is strictly bigger than negative 4. I'm sorry, x is strictly the same as negative 4.5. So I'm not looking. I only have 2 left. Okay, so let's look at these side by side. This says I'm choosing just this number and with no shading, nothing else. And this with the open circle means I can be anything else but this. Well, I'm looking for exactly the same, so I'm looking for 5 here. This says x is not negative 4.5. Well, think about this. If I said, hey, you can't choose this one, I'm implying you can choose any other thing that you want. So take a look at this guy. Everything is shaded except for this open circle. That means I can choose any number but the open circle. That's what I'm looking for in this guy. Bam! 6. Kind of a tricky problem. Lots of thinking to do in this problem. But in the end, how do you break this open? Well, two things. One, you have to know what the symbols mean, whether they should be open circles or closed circles. And the second part, it's all about picking a test point. So if you kind of review number 3, this one totally worked because it had the right symbol. And when I picked a number that was being shaded, like negative 10, this still worked. Negative 10 is smaller than negative 4.5. Bottom line, the test numbers worked. Great strategy to figure out which is which on this section. Moving to number 2. Excuse me, I mean number 6, the second one that you were assigned. You want to write an inequality statement to represent the graph below. Now, this is tricky, but you guys can do this. We have to simply start right here. It seems to me the points of contention are 5 and 2. So whatever numbers I'm looking at is going to be kind of wrapped around negative 5 and negative 2. And we've been using x, so let's go ahead and use x as well. So that my kind of curiosity then is, what kind of symbols do I put in here? Well, first of all, hope you note the open circle. So is this going to be strictly greater than or less than? But let's take this one piece at a time. What I mean is this. Forget about the left-hand side. Let's just check out this side right now. Let's try to write an inequality for this. What kind of x's, what kind of variables do I want are represented by this line? Well, 6, 7, 8, 9, 10, 11, 12, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Are those numbers bigger than or smaller than 2? Well, obviously they're bigger. So that's what I have to write in right here. This part of the number line has to reflect this part of the inequality. So if I want x's that are bigger than 2, I have to write that here as well. X's that are bigger than 2. I want x's that are bigger than 2. We're going to repeat this process and this thinking on this side as well. Forget about the 2. We wrote that in. Let's talk about this guy. What kind of x's am I looking for now? What kind of varied numbers am I looking for now? Well, check this out. If I'm starting at negative 5, the numbers that are shaded, that are covered, are negative 10, negative 9, negative 8, negative 7, negative 6. Well, are those numbers bigger than or smaller than negative 5? Again, think about money, think about temperature, think about easy examples to help process this information. Would you rather owe someone $10 or owe someone $5? Would I rather owe someone $9 or owe someone $5? Is it better to have negative 8 degrees or negative 5 degrees? These numbers are all smaller, inferior to negative 5. So I definitely want to choose numbers that are smaller than negative 5. So the proper way to read this is really two different ways. I want x's that are smaller than negative 5 and then x's that are bigger than negative 2. Now these don't exist at the same time. So really, I'd want to use the word or to describe this. I want x's that are smaller than negative 5 or x's that are bigger than 2. All right, let's go with the next one. So this is very similar. We're going to use a similar tactic as well. I see a 5, I see a 2. That's where we'll start drawing the inequality. And then we need a variable to choose in the middle. X is standard. Now we need to break this down into pieces. Okay? So let's talk about this part first. What kind of numbers are right here in relationship to 2? Are the numbers being shaded bigger than 2 or smaller than 2? In this case, definitely smaller than 2. 1, 0, and all the negatives smaller than 2. So we can put that piece into our writing. I want x's that are smaller than 2. Now should I put a little line there? What do you think? Should I put that line there? Oh, of course I should put that line there. It's an open circle. It's a strictly sign. I can't be 2. I got to be smaller than 2. Now let's shift it over and check out this side. What kind of x's are here? Well, negative 4, negative 3, negative 2, negative 1, 0. Those numbers are all bigger than negative 5. So my symbol again has to reflect that. I want numbers that are bigger than negative 5. Now, again, the way to read this, and again we've been saying this all day, split it up into two pieces. Negative 2. I want x's that are bigger than negative 5. Smaller than 2. X's that are bigger than 5, x's that are smaller than 2. Again, it's kind of dual reading system. Now, in this case, they can occur together. You can actually pick a number that satisfies both at the same time. So the key word in this sentence is an and. So I want x's that are bigger than negative 5 and smaller than 2. It can happen at the same time. Staying sharp. Simple work. You guys should be easy doing this. You guys should be doing this pretty easy by now. Again, remind yourself. Grrr. Bigger, smaller. Okay? So 1.09, 1.1. This is tough. I know what you guys are thinking immediately. Some of you guys, 9's bigger than 1. Yeah, but would you rather have $1.09 or $1.10? Bigger. Okay, so $1.10 is bigger than $1.09. 8/7 or 1.1. So on this one, we're really going to have to maybe convert one to a decimal or the other to a decimal. So by the magic of TV, let me do that. Okay, and we're back. Got the calculator up, so let's actually convert this guy to a decimal. 8 divided by 7, with my division sign. 8 divided by 7 is 1.14-ish. 1.14. So which is bigger, 1.14 or 1.10? Well, $1.14 or $1.10? I want the $1.14. Even it's minuscule. Oh, they're trying to get us. Which one is it going to be now? They flip some negatives on us. Well, we're not going to get tricked by this. We're still going to think in the same mode, but we want to owe less money. So 1.09, 1.10, 1.09 is definitely the bigger in these two. Okay, so this should be negative 1.14. Which is bigger? Well, which would rather owe, $1.14 or $1.10? $1.14 definitely is more money to owe, which makes $1.10 the bigger of the two. Right. Which pair of x and y coordinates appears in the tables for both functions? So I have this equation, I have this equation. I'm looking for table values that occur in both, and we'll simply circle them. So let's just go down the list. -4 is not the same, -3 is not the same, -2 is not the same, -1 is not the same, 0 is not the same, 1 is not the same, 2, 3 is not the same, 4 is not the same. Well, I guess we have to give up, right? We didn't see any that actually occurred at the same time. Am I right? Well, of course not. We had to do a little more work. Unless you caught that I actually did pass a value that is the same. Go back, rewind it. Did you see the mistake I made? Intentionally made, maybe not intentionally made, we'll see. But the point being, there is a value in this table. It does occur in both. It happens right here at the 3. So 3, 1 actually does appear in both. So that's the one we're looking for. So just kind of keep in mind, you gotta be careful. It's easy to get blind looking at all these table values. But -3, -1, I'm sorry, +3, -1 is a value that occurs in both. Okay, what are the coordinates of the point listed at the intersection of two lines of the graph? Well, let's take a look here. Let's get in here a little bit. I don't really know exactly where that point is, but we can probably make some pretty good conjectures. I'm looking at a number right in between 2 and 4, and then and right in between 0 and 2. And if we zoom out, you can definitely see that's what I'm looking at. Between 2 and 4, between 0 and 2. So I'm looking for this value probably to be 3. And this value probably be 1. Now, in honesty, we're just guessing. We don't know for sure. So we might actually be wrong about this. But my guess is that we're not. That if we're looking at a value that looks pretty much in between and we're approximating, this is going to work out okay. So I'm looking at 3, 1 for a final answer. Happy face. Okay, what is the slope of the line? A slope triangle is drawn for you. Well, we got to get a little bigger here. Like, this isn't big enough for me. I'm getting old. I need to actually see this thing. So a couple things we need to review, just very quickly. Kind of recall that in terms of a slope, an m value, we're looking for the change in y, delta y, over the change in x, which is the same thing as our very famous rise over run. Okay. So in this case, we're looking at the vertical change divided by the horizontal change. A lot of different ways we can all represent this lovely thing called slope. Bam, bam. Okay. So checking in on our change in y, change in x, that's going to be our change in y. This guy is going to be our change in x. So change in y looks like a 1. Change in x is 1, 2, 3, 4. So our slope in this case, change in y is 1. Change in x is 4. Our slope is 1 over 4. Write equation for the line in question 5. Answer with supporting work. Now I'm actually going to go back so I can actually look at the thing. Because if I'm going to write an equation, I need to be able to see it. I also need to recall that since I'm looking at a straight line, I know my equation is going to fall into this form, y equals mx plus b. Now to write this equation well, we got to figure out what the pieces are. Well, the x and y are the variables. They're going to stay variables. Here, in this case, is going to be the slope, and the b is going to be the y-intercept. Now look at this. I already have the slope I figured out in the previous problem, which means I only need to find the y-intercept. Well, looky there. Y-intercept in this case is going to be 0, making my equation y equals 1 over 4x. Proportional, linear. And there you have it. So again, I hope this video helped, guys. Spread the word. Get some people to do their homework, man. Like you can be that mother hen in the room that gets those people to do the work. You guys can be the community member that really pulls our community together and gets people on the right track. So if you find these incredibly helpful and if you find them marginally helpful, get these guys to watch them, man. Like go ahead and get them the information they need. Get them over to your house. Get them studying this math. Thank you guys for watching. Have a good day. See you tomorrow.